Okay, our last speaker here this afternoon is Damien Eggermont, talking about, again, more multiple combination of headspace extractions.
Thank you. First of all, I would like to thank the organizer to let me the possibility to share my results. And today I will present to you and talk with you about the exploration of coffee brew aroma volatile profile using GC GC-MS, but combined with multiple combination of headspace extraction. But first of all, let's talk a bit about coffee. So coffee is a very variable market with a primary production export of $21 billion in 2017, with an overall increase of real coffee production for now 60 years. It's also of really high interest for industry, and so it's therefore also really interesting to learn more about the coffee in general in order to avoid fraud and adulteration during export, for instance, and to give custom control to custom. Sorry, and also has a very high complex matrices with about more than 1,000 of compounds, volatile compounds estimated. So it's really of high interest to learn more about these matrices. But then now I will talk to you about extraction. So extraction, and especially solvent-based extraction, exists in many shapes. So we can take, for instance, the solid phase micro extraction, the stir bar solvent extraction, the TD tube, or for instance, the more recent magnetic particles. They are present in different form with different advantages and limits. Some are highly automatable, some are less automatable, and some give better recovery for certain compounds, especially for polar compounds, where this can be problematic in some cases. But today I will talk with you about the SPME and a probe-like tool called iSorb, which is just in between SPME and SPME raw and stir bar sorted extraction. So the main difference between these two tools are the form, obviously, and also the solvent volume, which is much higher in the iSorb than in SPME. So let's talk a bit about the instrumentation. So here we can see that we applied a first sample preparation by Century from Max, so which is a solvent extraction with or SPME or iSorb. So the particularity is that we focus everything on a trap in order to release everything in a single shot in the GC. So after the sample preparation, we have the GC-GC separation. So here we used normal set of apolar-polar column with so we use a Shimazu triple quad instrument with a rival field flushed flow modulator of substance. So the first thing that we did was to compare the SPME and the iSorb. So yes, I need to precise that iSorb has been used in this case with PDMS coating. So the first thing that you can see is that if we only compare PDMS solvents, the SPME PDMS extract almost nothing except alkanes. And if we increase the solvent volume, we usually increase the coverage of extraction. And so we can reach the selectivity of the SPME triphasic. So this is explained by the absorption theory, where we know that if you increase the sorbent volume, you shift the curve of recovery toward a more polar compounds. So then we did a quick conditional optimization. So firstly, we optimize the time and the volume. So here I show a heat map representing representative of the compounds that we have. So we try 1 milliliter and 4 milliliter, and between 10, 30, 40, and 60 minutes. And so we reached the conclusion that the most effective, the most efficient conditions are 1 milliliter extracted during 30 minutes. We didn't try below 1 milliliter because if we had less than 1 milliliter, we observe a crust formation, which lead to entrapping of compounds, which may be non-representative of the sample. So after we did, we optimized the temperature, and so we try different temperature. We try 30, 40, 60, 30, 40, 50, 60, and 75. And so we get at the conclusion that we will stay at 60 degrees because it's the temperature at which most hot beverages are consumed. So in order to be more representative of the human perception, we will stay at 60 degrees. So now I will talk about a bit about the multicumulative trapping extraction that Steven has already introduced earlier. So this is, we just repeat the sample preparation several times, but we trap everything together on the trap. So we use two different approaches. We use single vial and multi-vial. The single vial is what Steven has shown with olive oil. So it's everything on the same vial. So with the same aliquots and the same sample. Whereas the multi-vial is the same extraction on the same sample, but from different vial. So this has been done, the single vial extraction has been done only in SPME because we can't use this approach with isorb because when you pierce the septum, you can't reach an equilibrium because the septum is completely pierced. Whereas with SPME, you can find a way to reach a new equilibrium even if the septum is pierced. So the first thing that you can see here, so in the middle you can see the bar plot representing the number of compounds that we can identify, that not identified, but that we can find on the chromatogram. So the first thing that we can see is that between the single extraction approach, so 1 time 30 minutes of extraction, and the multi-vial multicumulative approach of 3 times 10 minutes of extraction, we really increase the sensitivity of the extraction because we see that we extract more, we extract a higher number of compounds than with the single extraction. And so for PDMS, we observed that there are no discrimination during this, which is completely normal because you are adding the same extraction, exactly the same extraction on the trap. But we try with the triphasic phases, and the result was completely different. But one thing really interesting is that the SPME, the multicumulative extraction of SPME made from the same vial and from different vial lead to the same thing, to the same result. That means that even after 3 times 10 minutes of extraction of the same vial, we obtain the same results as if we have done this on different vial, meaning that we were on a completely saturated situation. So in this case, we will see later and try to see what happens if we are in unsaturated headspace. And so for this, it would be great to use 1 milliliter of sample. So we applied a different technique on the study of the packaging impacts, of the impact of the packaging on the coffee aroma profile. So we had three different packaging. So two are espresso capsules, Nespresso capsule, and and the other is coffee coming from a multi-layer aluminum bag that we use the coffee to fill a refillable capsule in order to use it with the machine. So the main difference between these three samples are the fact that we have one cap that is made from lignocellulosic material, which is compostable, firstly, but also not permeable to gas. And so we use a commercial coffee machine to standardize the procedure of coffee brew. So I display to you the data workflow here. I won't go into many detail, but to make a long story short, we applied tile-based integration, and then feature reduction by random forest, followed by visualization and hierarchical cluster analysis. And so this is what we obtain. So I don't know. Yeah, okay. So the first thing that you can observe is that we obtain the same clustering ability from the different approaches. So we easily discriminate biodegradable sample from the other. Then if we look more in details within the feature that we have extracted or the compounds that we can obtain, we can find some, we can identify some different key odorant compounds such as 2-vinyl guaiacol and guaiacol. And what can be observed is that the key odorant compounds are present in a less amount in the biodegradable capsule, which is already known for oxidized sample or for aged samples. But if we are talking about oxidation marker, we already found some oxidation marker within. So most of them are present in higher amount, in less amount, sorry, in a biodegradable one, except the furfural, which is known to be a degradation of the furfuryl alcohol. Another thing that we have observed is that we have a group of features that we were not able to identify that are coding for early eluting compound, and it's on this part of the chromatogram on which we can find some acetic acid, for instance, and some sulfurous compounds. So what we have currently. So the first thing that we have done is an optimization of an isotope extraction. Then we have seen that with the multi-vial, multi-cumulative trapping extraction approaches, we really burst the sensitivity. But which is interesting is that, okay, we increase the sensitivity, but we don't really increase the information level, since we are able to cluster the same, more or less the same way, the different sample. And then, yes, we observe that even if we use a different tool, meaning a different sorbent volume, but in another way, we are able to reach the same performance in terms of clustering capability. But everything was done on PDMS isorb. Because now that new phases are released for the isorb, we can try to see what is the difference between these phases. This is a work that has already been done really for a long time ago in SPME, but now we can also see how the phases will behave in isorb. But this is just a preliminary results, and further investigation are ongoing. So this is what we obtain as chromatograms. So the first thing that we can directly see is that the DVB-PDMS seem to be the less interesting extraction, whereas between the CAR-PDMS, the CAR-DVB, the triphasic, and the PDMS, the question is a little bit tricky. One surprising conclusion that we had is that the PDMS was quite interesting to extract the early eluting compounds. But if we look at the middle part of the chromatogram, what we can observe is, so the conclusion for the DVB-PDMS seems to stay the same. And definitely in terms of recovery, we observe a better extraction in the CAR-PDMS, but we can find some little compounds that are different from one to the other, but this has been to be better investigated. But when we are looking at the low volatile compounds, the result is completely different. I mean, for the DVB-PDMS, we observe much more compounds extracted for phthalates, for instance, or for mineral oil. So maybe that the DVB-PDMS would be better for the contaminant analysis. So as a conclusion perspective, so there is a lot of exciting possibilities that we can find with this different tool that we have. So just to sum up, we have the difference in terms of sorbent volume, and we have the difference between the phases, and also we can use the multicumulative trapping in different modes. This leads to a great modulability of the extraction between sensitivity and coverages. So we can really tune the extraction based on what we want to observe on our sample. And so as perspective, we really want to explore more the MCT approaches based on coffee or on other really interesting matrices. And we really want to see if we could maybe use the multi-vial multi-cumulative trapping extraction for the contaminant part, since we increase the sensitivity, and the SV we need to see the impact to study more the impact on not fatty based solution, because Steven worked on fatty based sample, but here, from what we observe, is different. The behavior is completely different. So we would like also to try with a less amount of sample by using, for instance, the total volatilization technique, and this will allow possibly to reach an unsaturated space and have better explanation on what phenomena are going during the extraction. So I would like to thanks again the organizer of this conference, and thank you for your attention.